Hi and welcome to the Matrix Algebra for Dummies. In this lesson you will learn how to multiply matrix by another matrix. This operation is usually the first place where problem starts for those who are new in matrix algebra. This is because there are many steps which must be done correctly and therefore many ways to make an error while doing matrix multiplication. So in this video I will show you how to multiply two matrices by solving different examples with matrices of different sizes. Unfortunately for you, the only way to master this matrix operation is to practice a lot. Now, I hope that you are ready and we can start. Of course, if you want to get regular updates about new lessons, please subscribe to my channel. Before you can do matrix multiplication, you need to remember few rules. First rule is, to multiply two matrices A and B, number of columns of matrix A must be the same as the number of rows of matrix B. This means that order of matrix A must be m by n, while order of matrix B must be n by p. Second rule is, result of the multiplication of two matrices A and B is going to be matrix C with order m by p. And third rule is, product of two matrices is not always commutative, that is, A times B is not always equal to B times A. Okay, now it is time to solve our first example. In this example we will multiply matrix A by matrix B. Order of matrix A is 2 by 2, while order of matrix B is 2 by 4. Resulting matrix C will have order 2 by 4. Now, how to calculate the elements of the matrix C? To calculate element C11, you must select first column of matrix A and first row of matrix B. Then you multiply each element from the selected column by corresponding element from selected row and sum all these products. To calculate C12, you select first column of matrix A and the second row of matrix B and then repeat previous procedure. For C13, you select first column and third row. For C14, you select first column and fourth row. For C21, you select second column and the first row. For C22, second column and second row, and so on. Okay, now it is time to multiply these two matrices. To calculate first element, we select first column and the first row and write 1 times 1 plus 2 times 2. Next element is going to be calculated from the first column and the second row, that is 1 times 3 plus 2 times 4. Next element 1 times 5 plus 2 times 6, and next element 1 times 7 plus 2 times 8. Now we go to the next column, 3 times 1 plus 4 times 2. Then 3 times 3 plus 4 times 4. Then 3 times 5 plus 4 times 6 and 3 times 7 plus 4 times 8. Then we need to calculate all this. We get 1 plus 4. Next element 3 plus 8, then 5 plus 12, 7 plus 16, then 3 plus 8, 9 plus 16, 15 plus 24 and 21 plus 32. When we calculate all this, we get 5, 11, 17, 23, 11, 25, 39, and 53. And that's all. Okay, but what will happen if we try to calculate b times a? Let's first rewrite these two matrices and write matrix b 1, 2, 3, 4, 5, 6, 7, and 8 times matrix a 1, 2, 3, 4. In this case we cannot perform multiplication because order of matrix B is 2 times 4, while order of matrix A is 2 times 2, and we can see that number of columns of matrix B is not the same as the number of rows of matrix A, and this is one of the reasons why matrix multiplication is not a commutative operation. Okay, now it is time to solve our second example. Here we will multiply matrices A and B, where matrix A has order 1 by 3, while matrix B has order 3 by 1. So let's first multiply A times B. Now let's rewrite these matrices. Matrix A 1, minus 1, 5 times matrix B 2, 3, 6. Now we have one column and one row, and we write 1 times 2 minus 1 times 3 plus 5 times 6, which equals 2 minus 3 plus 30, which equals 29. Now let's multiply b times a, and let's see what we are going to get. First let's write matrix B 2, 3, 6 times 1, minus 1, and 5. Now matrix B has order 3 by 1, while matrix A has order 1 by 3. Now the resulting matrix will have order 3 by 3. So let's calculate. First column, first row, 2 times 1. First column, second row, 2 times minus 1. 2 times 5. Now second column, 3 times 1. Second column, second row, 3 times minus 1, and 3 times 5. Now 6 times 1, 6 times minus 1, and 6 times 5. Now this equals to 2, 3, 6, minus 2, minus 3, minus 6, and 10, 15, and 30. And again, you can see that A times B isn't equal B times A. In this example, we will multiply two matrices with same order 2 by 2. So let's first calculate A times B. A times B equals matrix A, that is 5, minus 1, 6, 3, times matrix B, minus 1, 4, 2, 0, and this equals first column, first row, 5 times minus 1 minus 1 times 2, then 5 times 4 minus 1 times 0, then 6 times minus 1 plus 3 times 2, then 6 times 4 plus 3 times 0. This equals 2 minus 5 minus 2, 20 minus 0, minus 6 plus 6, and 24 plus 0, and this equals to minus 7, 20, 0, and 24. Now let's calculate B times A. When we write first matrix B, minus 1, 4, 2, 0 times matrix A, 5, minus 1, 6, 3, and we write then first column, first row, minus 1 times 5 plus 4 times 6, then minus 1 times minus 1 plus 4 times 3, then 2 times 5 plus 0 times 6, then 2 times minus 1 plus 0 times 3, and this equals to minus 5 plus 24, then 1 plus 12, 10 plus 0, and minus 2 plus 0. When we calculate this, we get 19, 13, 10, and minus 2.